Welcome to our full paper presentation on identifying machine-paraphrased plagiarism. My name is Jan-Philipp Wahle, and this paper is a joint work in collaboration with Terry Ruas, Thomas Foltýnek, Norman Meuschke, and Bela Gipp. Let's start by dissecting the title. Plagiarism describes the use of ideas and expressions of another author as one's own work without proper source acknowledgement. Nowadays, plagiarism is a severe problem for research and educational institutions, as students can receive credits and degrees without achieving their educational objective, and researchers can receive funding and reputation for ideas from others. Plagiarism still has the barrier in that it is time-consuming to paraphrase and rewrite text, such that it is convincing for humans and that plagiarism detection systems cannot spot it. In recent years, a new trend has formed through the availability of AI solutions to generate and paraphrase text that is almost indistinguishable by humans. Machine-paraphrased plagiarism describes the automated generation of convincing paraphrased examples. Consider the following text excerpt from Wikipedia about quantum field theory. In the first step, the machine paraphrasing tool identifies words that can be replaced by synonyms. A model then assigns probabilities to each synonym candidate. For example, the model used here assigns the candidates quantitative, mathematically, and cumulative to the word numerically. Then the model chooses from the candidates to replace the source word. We observe that machine paraphrasing tools allow plagiarized to generate many paraphrased examples effortlessly. To counteract this problem, we approach answering the question how to identify machine-paraphrased plagiarism. We compare plagiarism detection systems based on text matching with machine learning classifiers, neural language models based on the transformer architecture, and human performance. In total, we study a combination of 5 word embeddings, 3 machine learning classifiers, 8 neural language models, 74 human evaluators, and 2 plagiarism detection softwares. As the problem of machine-paraphrased plagiarism is still emerging, we propose a comprehensive dataset for our training and evaluation. Therefore, we use 2 paid paraphrasing tools. The example we just showed was paraphrased using SpinBot, which is a well-known API and used by tools such as Free Article Spinner. SpinBot approaches to change every other word in the source text. The second tool we use is SpinnerChief, which is one of SpinBot's competitors. SpinnerChief allows to change the rate at which words are replaced. We paraphrase examples with SpinnerChief in 2 configurations. The default frequency approaches to change every 4th word, while the increased frequency approaches to change every 2nd word, similar to SpinBot. In the following, we'll refer to default frequency as DF and increased frequency as IF. We compose our dataset of paragraphs from Wikipedia, arXiv, and student theses from non-native English speakers. Paragraphs provide a good trade-off between context and length, making it feasible for both humans and machines to understand and process it. The Wikipedia articles we selected come from the featured article category. Featured articles cover a wide range of breadth and depth in topics and have many revisions by experienced native speaker authors. We selected arXiv articles using the No Problem category from the XML parse repository arcxml-if. Theses include bachelor's, master's, and PhD level degrees from Mendel University Brno, covering a wide range of disciplines from economics to computer science. In total, we receive over 39,000 paragraphs from Wikipedia, 21,000 from arXiv, and 5,000 from theses that we consider as original work. For paraphrasing, we choose mutually exclusive articles between paraphrasing tools and don't reuse original ones. The number of paraphrased examples is less than 1% different than originals, except for theses, in which we retrieved less examples in general. In total, we have around 120,000 paraphrased paragraphs from We train machine learning classifiers and static word embeddings, as well as neural language models using the following methodology. We only use Wikipedia articles paraphrased with SpinBot as the training corpus. This allows us to show later in the evaluation that models can generalize not only between sources, such as archive or theses, but also generalize to two and independent paraphrasing tools. For each example from Wikipedia, the classifier returns a probability score for whether the example is original or plagiarized. This type of unaligned classification is close to the real case scenario in which the source is unknown and detection decisions have to be made solely on single or few examples. We optimize machine learning classifiers using a grid search over 8 parameters and neural language models with the default configuration for transformers. In the evaluation, we test models on all combination of datasets and paraphrasing tools, allowing us to show whether the model is generalized to the problem independent of source and paraphrasing tool. We measure the success of models using F1 micro, as original and paraphrased examples are slightly imbalanced. To show whether automated AI detection solutions are useful, we compare them to existing plagiarism detection software and human experts. We use 2 de facto software solutions for identifying plagiarism. Turnitin has the largest market share, and PlagScan is one of the best performing software according to the European Network for Academic Integrity. We test both tools by sampling paragraphs randomly from sources and paraphrasing techniques. We make sure to receive an equal number of paragraphs from each source and from each paraphrasing technique, so none of them is overrepresented. Then, we measure the detected text overlap exhaustively over all combinations of sources and spinning techniques. For a human baseline, we asked a total of 74 participants from the academic integrity community to rate excerpts from Wikipedia with an equal amount of examples from SpinBot, SpinnerChief's default frequency, and SpinnerChief's increased frequency. We measured the F1 microscore for each spinning technique and used the average as a baseline for human performance. Here we compare detection methods over all data sources on paraphrased examples from SpinBot. Turnitin and PlagScan fail to distinguish original from paraphrased examples with an average of 12% text match. The human baseline is relatively high, with 78%, a significant portion of example was classified correct by human experts. Machine learning methods can even do better with 86% F1, and neural language models, in particular Longformer, classifies almost every example correct in our evaluation set. Remember, our training data set was also paraphrased with SpinBot. Neural language models seem to capture the way SpinBot paraphrases relatively easily, thus achieving extraordinary high results. The interesting question now is whether they can sustain their performance when they have to generalize to unknown spinning techniques. When evaluating on SpinnerChief's default frequency, which paraphrases fewer words than SpinBot, Turnitin and PlagScan improve their text matching score by almost 33% on average. AI classifiers in humans reduce significantly in performance compared to SpinBot. The human baseline drops to 65%, and machine learning classifiers cannot obtain superhuman results. Neural language models still outperform humans by more than 4%. We assume the decrease in paraphrased words makes it increasingly difficult to find anomalies, which is why both humans and automated methods perform worse. Text matching software, on the other side, receives more context from the original source, which increases the probability to find good matches. Evaluating SpinnerChief's increased frequency, which is similar to SpinBot's, AI classifiers perform slightly better, which we assume is due to the model's understanding of word patterns. Machine learning classifiers can match human experts, while language models consistently outperform humans. This evaluation shows neural approaches can generalize to new paraphrasing tools with strong performance. Also, we expect that the human average will be lower in a realistic scenario in which readers do not get instructed to spot machine paraphrasing. In the real-world scenario, readers are not paying special attention to spotting machine-paraphrased plagiarism. When plotting the results over datasets, our identified trends intensify. All models perform similarly when the source is Wikipedia, which is the same as during training. When shifting domains to archive, machine learning classifiers and neural language models show their strength. Especially language models generalize well and seem to learn intrinsic features about paraphrasing, which enables them to outperform humans and others by significant margins. The same pattern can be observed for theses, in which neural language models perform significantly better than others. Text matching software has particular difficulties, which we assume is because they don't index theses. Wikipedia and archive is probably represented in Turnitin and PlagScan, while theses from the Mendel University are not. The experiments here showed that automated solutions for classifying paraphrasing can outperform human experts and widely used text matching software. Particularly language models could work as a great complement to plagiarism detection software, as they can spot machine paraphrasing. Thank you for showing interest in our work. You will find many more details in our paper, and we would appreciate if you take a look at it. We also would like to thank the reviewers and program chairs for their constructive feedback on the paper and the nomination for Best Paper Award. The source code is publicly available on GitHub, and if you have any questions, do not hesitate to contact me with my details below.